Oh, no, they didn't. Looks like it's being contradicted here. There's a story earlier that was suggesting that quantum computers could actually reverse time even just a half a second to check computations. And the author of Intelligent Mechanics says no, scientists didn't just reverse time with a quantum computer. Now, let's see what their interpretation is. It was published March 14, 2019. It quotes all kinds of articles that was talking about this subject with the IBM Q's quantum computer, IBM quantum computer, and they got all kinds of cited papers that came out. The claim here is the research towards investigating time reversal and backward time flow. This guy is seriously offended by this whole thing. It says if you had difficulty understanding how scientists accomplished such a counterintuitive feat, don't worry, they didn't. Okay, so he's completely dismissive already. Since we don't know, let me say right now, we don't even know how quantums work. But he's going to let you know they didn't do anything that they couldn't have done. And I believe he's right. They didn't do anything they could not have done. Just like quantum computers, they didn't believe they could even do them. But they're doing them now. And so let's read on and see what they say. Some simple physics models are symmetric in time. Think of an idealized version of each of Earth orbiting the Sun. And he'll go on to tell you that think of the Earth just going in a counterclockwise direction. Reverse time, and instead the Earth will travel in a counterclockwise orbit. Both are equally realistic. Okay, so or think of two billiards colliding, and you can run a video in either direction. Seems physically plausible. The real world is not that way. Think. Okay, he's going to go on to the VHS explanation here. Things look different going forward in time from how they were time reversed in a number of different ways among the entropy, very loosely speaking. Entropy meaning, I think the loss of heat, enthalpy and entropy are the two reversals. One's a loss of heat, the one's a gain of heat. So nothing can gain heat without, or energy without some sort of reaction. So he's just saying it's impossible in that aspect with regards to those physics properties. This is the law of both physics and common sense. For fun, the sad explanation of how strange reversing the flow of time would make things, check out the Time Arrow, which might be interesting. Time Arrow by Martin Amis. And if you would really want to get into the weeds of physics and time travel, try here. Okay, so he's got a hot link to something that might be quite interesting if you're into time travel and the ideas, which I kind of am. I mean, I like the idea of the mechanics of what's going on and how far we're really going. And, what are the pretense of suggesting this? Since the scientists that are working on this are the ones that are suggesting it. This guy is the one that's writing about it. So if they didn't invent time travel, what did these scientists actually do? And he goes on to the VHS. Those of you who don't know what it is, VHS is much like tape deck. Oh, we don't know what that is either. So essentially it's just a wound up piece of material that generates data on a magnetic strip that can be viewed or listened to depending on your media type. And just like a DVD can be rewound and forward, just like an MP3 or MP4, you can rewind and forward. Essentially, that's what he's saying the computer's doing. That's all it's doing. And with that said, if you've never seen it before, this it is kind of neat. He says it might let you see things like stream flowing back into the tea kettle, or Humpty Dumpty spontaneously assembling from a jumble of broken pieces. It appears to reverse the arrow of time. The paper in question describes quantum computing inversion of such a video running in reverse. A closer analogy is a lens, like what would be found in a telescope and a microscope or eyeglass. A lens can be used to focus light, reversing the dispersal of light that had gone out of focus. The authors of the paper from Moscow's Institute of Physics and Technology, I'm not really sure how to say that, Argonne National Laboratory in Illinois, ETH Zurich, has said the technique might be useful in testing quantum programs. This is correct, but it's a lot less interesting than a time machine. I think it's absolutely fascinating. All right, don't make quantum computing boring. It's not boring. Okay, first of all, quantum computings, everybody, heads up with this. There is no real way to test how efficient it is besides testing itself. If this is a grand experiment, if this was a scientific experiment or an FDA drug, there's nothing to test this against. They're currently conducting scientific observations with the use of formula to process very technical, complicated formula and functions. And there's nothing we can. There's no control group here. This is the control group is actually the test group, and the outcome is the outcome, and it's going to be the same. They're literally making up reality as it goes along with one method of testing it, reversing this thing to see if everything is checking out, I guess, if you will. And that's dangerous because it's the same system that you ran it through. It's like me or Iran doing a nuclear testing or doing their own inspections. They said everything came out right, and you just kind of take them for their word because they're the only ones that are going to have the eyes on the equations. So this quantum computer is absolutely fascinating in a lot of sense because we're getting equations, we're getting formula. People are getting some validation from their own formula that are coming up, and they're able to test their formula through this machine. It's an open machine. You can sign up for it and use it. There's a lot of information about it. There's a lot of excitement, but there's a lot of concerns, and I think it's more concerning than even the CERN project, because the calculations you can generate and then actually test on your own, if you are desk clerk physics, you love physics, you know how to computate physics. I never really got past calculus. I love it. I can still make a logarithm. I haven't gotten to the physics area too much. This is an amazing machine, and it's the suggestion that they can go back a couple seconds or a half second even to check an old computation in some sense, given the fact that they're doing it with a quantum. I mean, this thing is split. They're twins that are. I mean, you have to look up the information on this, but there are some odd phenomena that happens with these quantums, and how they actually figure out and work this machine around these phenomenons, these unknown variables or the unknown behaviors of the quantum. Obviously, I don't know. So I think they're absolutely interesting to read about here. And they go on to talk about resimulating time reversal process of your computer. Then you can reverse the direction of time simply by reversing the direction of simulation. From a quick look at the paper, I confess that I don't understand how it becomes more profound in simulation is being done in IBM quantum computer. It's far more profound, okay? And that said, maybe it's not that profound or more exciting than a regular computer. Maybe we just took our computers for granted because they are doing some amazing things. I mean, if we think about some sort of game or simulation game that we can reverse for that two-dimensional space, we are changing the fabric of time for this game system. And if we make a game system complicated enough to actually have formula that includes chemicals and have a computing system big enough to have a virtual world that has such a high interactiveness that you can do chemistry in it and have biological processes occurring while interacting in some other dynamic way besides the scientific process, I think that really shows you how mind-blowing these computers can be, the ones that we have now and the quantum computers. So obviously the quantum computers would be better fit for this task, given the fact that they can carry out these tasks much quicker. And how, I still really haven't figured it out. I read quite a bit on it. So they're saying no time travel here. Even if they figured out how to manipulate these photons, these quantums, to compute things and then to do reverse computations. And I think it's going to be something they're going to look at anyways. I think there's going to be government programs that are going to look at it. They're going to see how legitimate it is. They're going to wash this thing probably 10 times over. And what you're going to see is just rhetoric from these kind of people that says, not interesting. But it is interesting, and maybe just the realm of science fiction, who knows. So other people agree that this is actually given a bad name, and it didn't violate any thermodynamics or law of physics, which it didn't. And that's the amazing thing about it. We can run a simulation, we can reverse that simulation, and that formula can represent everything in the real world, yet we did not violate any laws of thermodynamics. That is amazing. I mean, if we're simulating everything that's in the real life with a formula that can do so with some sort of accuracy, and if we continue to get accurate and more specific about the formula that's representing our real Earth, I mean, you're really talking about mastering something, reversing something, and then not breaking any laws of thermodynamics. I mean, that is amazing. So, how far we'll be able to go to understanding our physical world, to be able to reverse this effect and to actually say, wow, we just simulated an area of, say, a 20-foot square area, and we simulated all the biological, chemical, and atmospheric conditions in a computation, and we reversed it. Essentially, you are breaking the laws of thermodynamics at the same time you're keeping them, because the amount of heat that you're expending really would be within your computer now. So if he's not amazed by any of this, then I'm not going to hang out with this guy on Friday night. So he's right. Well, wild headlines don't just give quantum computing a bad name. They do damage to science as a whole by convincing the public that science is bewildering. It's beyond their comprehension. It's not. If you look into this stuff, you're curious about it, you're going to find out what the limits are, what they aren't, why they would suggest any of this stuff. And it could be the beginning of your interest into physics or quantum computing or quantum physics. So I don't think it was bad PR. I like this article just as much. You do have to have an equal balance, look at things and see whatever the other people are trying to say. So I appreciate you watching. Hit the like button if you liked it. And see you again. Thanks for joining me on The Curve.